Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look at how to do runtime profiles of your PowerBasic applications. When you are creating an application, either in the Windows or console compiler, your first priority is likely to be that you want the application to do the job it was intended to do, that is to run without errors and produce the correct output. However, once you have achieved that objective, you may well want to look at the performance of the application. If we look at the Windows compiler first, where you have developed a client application for users. These users may navigate through a series of screens to perform some task. If having clicked on some object on screen, for example a button, there is a significant delay before the next screen loads, users can get impatient, and it reflects badly on their appreciation of your application, even if it is producing the correct output. For the console compiler, while the user may do something to trigger the start of the console application, they may not wait around for it to complete. Alternatively, the application may run in the background, without any user participation at all. So while there isn't the problem of users expecting parts of the application to run quickly, there may well be a need for the application to complete within a set time period. A 10-minute run may be considered acceptable, but a 2-hour run might not be. So how can we profile our applications to narrow down where in the application is a good place to start to look to optimize the code? We're going to create a simulated application here with a number of functions which are going to be called with delays within them. And we're going to use the profile command to tell us how long the application has taken in each of these routines. In order to get this to work, we need to change one line of code in our application. At the moment we have this command tools off. Tools off will turn off all the debugging facilities in your application once it's compiled. We'll change this to tools on as we're going to be doing some profiling. At the moment we only have one function in the application. This is the PB main function. The command we're going to use is the profile command. The profile command should only appear once within your application, and that is where you wish the profiling to begin. So we're going to put the profile command as the very last command in the PB main function, but it will not profile anything within PB main itself. So there is our profile command at the bottom of PB main. It takes only a single parameter, and that is the name of the file into which the profile report is going to be placed. So if we create a subroutine or a function within PB main, which is going to kick off our application. So we're going to create a function called start processing. So in this function, we're making a call to our log to say the processing has started. We're then sleeping for 2 seconds, 2000 milliseconds, and then returning to the PB main. If we compile this now, and we run our application, the application will run and finish. Now if we have a look in the folder, we'll see we have a profile.txt file. If we open that file up, we will get a list of the functions within our application. There are 2 additional columns. The first column is the number of times that particular function has been called. And the final column is the number of milliseconds that the execution of those functions actually took. So we'll see our fun start processing took 2014 milliseconds. Now we know we have a delay, a sleep command in there for 2000 milliseconds, so the call to the function itself took 14 milliseconds. We can also see the call to the fun wait took 1283 milliseconds, and the preparing of the output took 212 milliseconds. Now if we put some more functions in our application, we'll get a better idea of what it's actually doing. So within the start processing function, we'll put a nested function. We're going to be calling another function called step1. And within step 1, we're going to do a for next loop. And that for next loop is going to call another function called step2. So our application, when it runs, is going to first of all call the start processing function. It will wait for 2 seconds and then call step 1. Step 1 will wait for a further 2 seconds and then it will go through a for next loop for 10 iterations. And for each iteration it will call the step 2 function. And the step 2 function will do nothing more than wait for half a second, 500 milliseconds. So if we compile that application now, and we will run it. The application will now step through each of these functions, and we're going to get an entry in our log for each call to the function. Now this will tell us how long each function actually took to run in milliseconds. So let's open up our file. And there is our file. Now we can see in here that the main function, the start processing, ran for just over 9 seconds. As this is the main function in the application, it obviously includes the runtime for any function underneath it, as start processing would still be running when fun step 1 was running. It ran for 7 seconds, and it was still running while it was calling step 2, and step 2 ran 10 times, and it ran in total for 5 seconds. Now, as we know the structure of the program, we can interpret these figures quite easily. We can tell at a glance which function was called the most, in this case step 2. So any reduction in the processing time of the step 2 function would benefit the whole application. Say for example we then decided that step 2 as a function was taking too long to run and needed to be optimized. We needed to recode or change step 2 in order to take it less time to process. So we'll leave this on screen and go back to application, and we will reduce the runtime for step 2 from 500 to 250 milliseconds. If we run that now, and we wait for the profile file to be created, and we can now have a look at the new profile file. So we'll see that the total time for start processing has gone down from 9 seconds to around 6.5 seconds. And the processing time for the step 2 function has gone down from 5 seconds to around 2.5 seconds. So because we've made a small change to one function which is called many times, we've made a benefit to the runtime of the whole application. So by use of the profile function, you can quite easily highlight which functions in your applications are being called many times, and which functions have the largest amount of runtime. So you can quite easily identify a function whether it's called many times or called only once, and using the time it took to run to determine whether you need to optimize this function or not. And having optimized your application to get running as fast as possible, you can then comment out the profile command, or alternatively change the command at the beginning of your application to mark tools as off. Hopefully you'll find profiling useful in your applications, but that's it for today. Thank you for watching.